Ever wondered how a pressure cooker manages to cook food so much faster than normal? Today on Knowledge Hub, we're diving deep into the science and engineering behind this everyday kitchen marvel, the pressure cooker. At first glance, it looks simple, a sealed pot with a locking lid and a small valve on top. But inside, some incredible thermodynamics are at play. Here's how it works. When you pour water into a pressure cooker and start heating it, the temperature rises as usual until it reaches 100 degrees, the boiling point of water. But unlike an open pot, the steam inside the pressure cooker can't escape freely. Instead, it builds up and increases the air pressure inside the sealed chamber. Under higher pressure, the boiling point of water rises, typically up to around 120 degrees Celsius or even higher, depending on the cooker. That means your food isn't cooking at 100 degrees Celsius anymore, but at a much higher temperature. As a result, the heat energy penetrates the food more quickly, breaking down fibers and starches much faster. This is why a stew that takes 2 hours on a normal stove can be done in just 30 minutes inside a pressure cooker. Now, let's talk about the key parts that make this work safely. The lid lock mechanism ensures that the cooker can't be opened while it's still pressurized, preventing accidents. The rubber gasket or sealing ring creates an airtight barrier between the lid and the pot, trapping steam inside. Then comes the pressure regulator valve, the little weight or vent you see on top. It's designed to release excess steam once the pressure reaches a specific level, usually around 15 psi. This ensures the internal temperature stays consistent without the cooker exploding. Some modern electric pressure cookers, like the Instant Pot, use digital sensors and microcontrollers to automatically monitor temperature and pressure. These systems adjust heat and vent steam precisely, maintaining the ideal cooking environment for everything from rice to meat to yogurt. When cooking is done and you turn off the heat, the pressure inside must return to normal before opening. This is called depressurization, and it can happen naturally as the cooker cools, or manually through a quick release valve that lets out the steam in a controlled burst. In essence, a pressure cooker is a perfect example of applied physics, using the relationship between pressure, temperature, and boiling point to transform cooking speed and efficiency. It's not magic. It's thermodynamics at work on your kitchen counter. So if you enjoyed uncovering the science behind everyday technology, make sure to hit that subscribe button for more fascinating deep dives from Knowledge Hub. And as always, stay curious.